So what? I'm sorry. That's you're referring to some equation that you need to work backwards from. So again, what's the hardest part about finding the answer to this question? The volume formula for a triangle? Yes. So finding the volume of a what? Pyramid. Anybody find that? What was it? Did anybody look it up? What is it, Eberhard? Yeah, so it's going to be equal to 1/3 the, and this is Lynch what you're referring to, area of base times the height. Exactly. That's a very good point. So in this case, it's 1/3. What's the area of the base? 20 times 20 times the height, which is 21, right? So it's going to be 400 over 3 times 21. So that's the area of the upper part. And how do you find the area of the... Oh, that's nice. That's just 20 by 20 by 20 squared times 60. Is that correct? So the total area, so that's the bottom part. So what's the total going to be? What's the total volume of this? What's the total volume of this shape? Who has it for me? Someone new. Yes, Kyle. 26,800, but that's not what the question's asking for, is it? What's the question asking for? Yes, and it tells you what? What does it tell you?
1 minute for every 150
cubic feet, right? So what do you have to do? So the total time is going to be equal to 2,600, 800 over what? Over 150, which is what? 172 minutes, right? Is it minutes?
I didn't get there.
If there's one row, how many cubes is it? 1. If there's 2, it's going to be that original 1 plus 1 plus 4. Yep, 5. Correct? So if there's 3, it's going to be 1 plus 4 plus what? 4 more than what you added on the last one, right? 1 plus 4 plus 4. This right here,
Oh, you're just combining.
I'm not putting them together is what I'm doing. Look, so this is, you agree that's the next layer, right?
Yes.
That layer is right there. The next layer is always, you're adding just 4 more on, right? This thing isn't going straight up, it's going up and out. You're only adding on 1 around each endpoint, right? Do you agree with that?
Yes.
Okay, I'm just writing it up because sometimes it's easier to see a pattern if you do it this way. So what is 4 going to be? It's going to be 1 plus 1 plus 4 plus 1 plus 1 plus 1 plus, sorry, that's too many ones, plus 4 plus 4, right? Plus what? 1 plus 1 plus, sorry, that's too many. So you need, I'm not going to write this whole thing out, you need the last layer, sorry. So it's the, oh, we have to be really careful about how we write this, don't we? Yeah. Did anybody do it this way? Does this look like a good way to do it? It doesn't? Okay, let's go with it. Let's go straight to the numbers. That's fine. What happens when it's n? You're looking for this when it's n, right? You agree with that? Okay, so you can look at these. This is your string of numbers right here. What did people do? How did they investigate this? What did you do, Kaylee? I liked what you did. What did you do?
I used my calculator.
Yeah, how did you use your calculator? What did you do?
Put in the 2
The 2 what?
rows.
The 2.
The
points.
into.
You plugged in those like 6 points, and then what'd you do?
I plotted it.
You plotted it? So let's do that. I think that's a great thing to do. I think it's 66, right? Is it 66? 76. Thank you. Okay, 76. Good. Let's go. But it's not. Is it wrong? It is 66. Thank you. Okay, it is 66. So we have this back in our calculator. Now we want to go to y equals and I'm going to turn off that graph and turn on plot. And when I do zoom, which one should I do? There's a better one. There's a better one here. Do you know what it is? Which one should I use? Zoom stat. Stat picks a really nice one based on the values that you've put in. So there's zoom stat. Now, does that look like a line to you? What? It does not look like a line. It does not look like a line.
Quadratic.
It looks like it's bent. That's correct. And it really looks like it goes through the origin. Looks like a quadratic is going through the origin. What did you do next after you graphed this? What did you do next, Kaylee?
Find the equation.
How do you find the equation?
Um,
Go back to the main screen and do what? Do you remember?
trace or
You have to go to
Stat,
stat.
calc, and we think it's what?
quadratic.
Quadratic. And here's the trick I'm going to give you. Quadrag. If you then go in and add on, I'm going to do it a little differently, but if I add on y1 right here, does anybody know why this is really helpful? If I do this, oh, does it give a really nice formula? Is that really good? Yeah, that's really, really good. There's no decimals there. That's fantastic. So you can take this if you really wanted to. Can you come up with the actual equation straight from that? What does an r squared value of 1 mean? Does anybody know what that means? That's perfect. That's a perfect fit. You want it as close as you possibly can get to 1. If r squared value is 1, that means it's a perfect fit. So what's the actual equation of this? Y equals, what's a? 2x squared plus, oh wait, minus what? Minus 1x, so x plus 0. So we have the number of squares is equal to 2n squared minus n. Here's the question. How do you know that this is a quadratic? You look at it, you guess that it's a quadratic. Does anybody know how you know that it's a quadratic? Jackman, what is it?
If you go to the
When-
and you look at the y value,
You look at the y value. So we're going to edit this right here. So you're looking at this chart, right, is what you're talking about? So we're looking at the y values. So you looked at the values, and you freeze the computer briefly. What do you look at in these y values, Luke?
you look at the differences of the y value.
Yeah, let's look at the dip here. What is it? It's going to be 5, and then 9, and then 13, and then what? What?
17,
And then what?
21.
And what do you look at?
One more time.
4,
Now
4, 4, and 4. And you notice now that the difference is constant. If after you doing this twice, the difference is constant, what do you know it has to be? Therefore, must be a not at the moment. The difference, the second difference is constant. Not going to explain it yet, but right now the second difference is constant, so therefore it must be a quadratic. So you hit stat calc 5 because we thought it was a quadratic regression, and then it was vars y vars function, and you hit. So that's what we're going to clip in. So this is really nice. It works with any data set. What should the r? You want the r squared value to be close to what?
1.
1. So if you do this out and hit enter, yay, that's really nice because it puts the equation there. I'm actually going to clear this one. And then when you do zoom, was it 9? What was zoom stat?
7, 8, 9,
9, thank you. It graphs it nicely. So here's the thing. It works every time, but let's say you didn't have a calculator. How would you approach this table of values right here without a calculator? That's fantastic. You get a rectangle, right? Now the real question is, what's the base here? And what's the height? Well, the height's easy. What's the height? The height is n. And what's the base going to be?
2 times n minus 1 plus 1. Because the 1 is the base, like the original one.
So look, yeah, if this is, this right here, this picture, what's the n value for this picture? This is n equals what? This picture is n equals what? How many layers are there?
6.
There's 6 of them, right? Does everybody see the 6? So what would the base be? We have 1, 2, 3, 4, 5 on each side. 5, and then there's 1 in the middle. So it's 2 times n minus 1 plus 1. And what he means by that is so you get a rectangle. That's what? It was n by 2n, 2 times what? N minus 1? Plus 1, right? because there's that middle column. So this right here represents the base of the triangle. Sorry, that's the height of the triangle. The height of the triangle. And what's this? The base. So if you do this out, you get n times 2n minus 2 plus 1. So what do you end up with? N times 2n minus 1. And what did we get for an answer up here? We got that right there, right? Multiply it out, what do you get? 2n squared minus n. Is that the same thing? I really like the rectangle idea. Does everybody see how that rectangle idea works? That's really cool. That's really, really cool. Good job. Yes, go ahead.
No.
Is that still a pretty good correlation? Yeah, it's not perfect though. So if but look because I put that y1 in there, it put the function in there completely. And if I graph this, it works. Is it going to go exactly through every point? No. So even if you mess up one, is that gonna kill the whole thing? Yeah. If you mess up one, it's gonna take it from being exact to really, really close. But is there an infinite difference between exact and not? Yeah, there's an infinite difference. Absolutely. Absolutely. Okay, let's change this a little bit.